Hello, welcome to the second video in the series of Apogee video guides. We are focusing on QGIS with these videos, and basically the first video that we did was a very quick crash course on how to draw a polygon in QGIS. I'm going to do a slightly longer video here where I go through some of the more technical elements of the shapefiles and the polygons, and what some common mistakes as well that people can make, ones to avoid. So the first one that I want to go through is the difference between a polygon and a multi-polygon. So we've got QGIS open here, and we've got a very simple layer list here. So this box on the left is showing us what layers we've got. Now, there's two types of layers in a QGIS file. There's raster layers and there's vector layers. Raster layers are just an image. So the Google mapping that I'm using here, this is a raster. It's a very large image. It's one file provided by Google. And even though it's got multiple zoom levels, so it almost functions like a vector in terms of how it looks, it is raster. So this is all stored kind of pixel by pixel in terms of the file. But what we've also got is something called vector files. Now, I don't need to go into the exact difference between these in terms of the data architecture, but to cut a long story short, vectors aren't defined as a kind of image. They're defined as a set of points in relation to each other in terms of their location. So vector files are much more usable when it comes to zooming in and out. You tend to get less pixelation, but they tend to be larger. So then it's not very practical to store something like a Google map file on vector. But something like this, which is a relatively simple polygon, that would be vector. So that's one difference. You know, you're going to get shape files in vector formats, like an Esri shapefile or a GeoJSON. Whereas you're going to get rasters like this Google Maps, you're going to get them in a different format. Polygon and multi-polygon. What we've got here in this layer is one polygon, and we can have multiple polygons in it as well, because it is a multi-polygon layer. And that's more or less the difference. You can have in a multi-polygon multiple polygons. So say I wanted to do another site next to this one. I wanted to do the other half of the housing estate here and just go around there. It wants me to give it an attribute, but you can see I've got both polygons here, and they're separate items. If I try and select them here, they're separate. One can be selected, the other can be selected, both of them can be selected, but they're not together. They're in the same layer, but they're distinct items. So that's a multi-polygon. And we tend not to use multi-polygons for a lot of platforms, because a lot of tools online that you can upload these into to display them, they don't like multi-polygons. What they want is one layer containing one polygon, which is called a single polygon layer. So if you were going to send this to somebody, for example, you would have the option of sending them this layer, or you could copy one of these shapes, paste it into a layer on its own, and then send that. And if you wanted to put it into a kind of website, then that would be the way that you would have to do it. So that's the difference between a multi-polygon and a polygon. I'm not going to keep this second polygon, so I'm going to go onto my delete part tool here and just delete that. And we're going to move on to another type of error, which is in terms of actually how it's drawn. So we'll go on to that next. Okay, so we've just covered multi-polygons and polygons, and we're going to do errors now. So a multi-polygon in some cases, like I was hinting at earlier, if you've got software that wants a polygon shapefile, then a multi-polygon itself would be an error type as well. You can have a special type of multi-polygon called a donut, and I'm not going to draw one of those here, but basically if you imagine this polygon, but it had a hole in the middle, like a circle, so you actually had one polygon in the center and then another polygon outside, so it looks like a donut, that's a multi-polygon as well, and they tend to be considered errors. But I'm going to just show you a couple of actual coordinate errors. These are problems that come up with the location or the order of the coordinates, and they can trip up a lot of code that reads shapefiles. So, and they can cause design problems as well. So it's good to have these ironed out. If you've got shapefiles that you want to put into a website to read or to present or software, it's good to get rid of these kinds of things. So I'm just going to show you three basic kinds, and they're going to be duplicate coordinates, they're going to be knots, and they're going to be crossovers. And they're very basic, all three of them, so I'm just going to go through them quite quickly. First one is a duplicate coordinate. You can see we've got this shapefile, which is a ring of coordinates going around in this shape. If I picked a coordinate here and I just added a coordinate, which is this little plus tool here, you see I can decide, I don't know if you can see actually, it's not particularly clear, but I can choose where this new coordinate goes. And if I just put it in exactly the same place as an existing coordinate, you can see that it becomes a green cross. This means that there are two coordinates in that exact same place. And that tends to be an error because the code struggles to differentiate what the two, because they're both in the same place and a coordinate is defined by its location. It's actually quite difficult for most softwares to actually tell that there are two coordinates, and it gets confused. So we're just going to select one and delete it, and that green cross will go away. And that's all you have to do to get rid of duplicate coordinates, is just delete them normally. The green cross will go away, and that is all good. The second type of error that we're going to go over quickly is a knot. And a knot is basically kind of like a duplicate coordinate, but there's an extra coordinate in between the two duplicates. So if I pick this coordinate here, this corner, and I add a coordinate next to it, and then I put my duplicate, so you can see what we've got is basically the shapefile goes to this point, and then it goes out to another point, and comes back in on itself, and then continues round. Again, because of the duplicate coordinate here, the software is not very good at determining what order these coordinates are in. So sometimes it can misread the one on the edge. And it's also just not actually a polygon anyway. That is a line. And a polygon shapefile can't have lines in it. It needs to just have polygons. So we need to get rid of this. And basically there are two ways to get rid of this. You need to delete the duplicate coordinate, and you need to delete the coordinate here that's kind of causing the issue. And once you do that, the problem should go away. So any knots like that need to be removed. And the third type of error is called a crossover. And this is a very, very simple one to show graphically, so I'm just going to do it. So you can see here we've got, if I just make this a little bit clearer. So you can see here we've got one polygon kind of crossing over itself into another, and this is all one polygon. This is again a problem, and it's a problem for two reasons. The first is that it's two polygons in one. That's the first one. And the second one is that the software is going to really struggle with this crossover point because it's going to think that that is a coordinate, but it's actually not. So yeah, these need to be removed. Most of the time, these will outright prevent your shapefile from going into a software. So again, it's just important to not have those. QGIS has a testing function for these. It's called a validity check, and it's a very simple thing to do. You select your polygon, and you go on to geometry tools here in vector, and then you go on check validity. Just run it, don't select anything. And what you'll get is basically a color-coded output that will tell you if it's valid or not. So that test has just produced a valid result. But you can see if I edit the polygon and I give it a knot like I just showed you, or a loop rather. So if I give this loop now and I do a validity check on it in this state, this will return a an invalid result because it's now got that error. So if I run the polygon, you can see this time the invalid output is color-coded brown, and that's what we've got. So when we select this, we also get an indication via a little dot, little point of where the error is, and you can see it's exactly where the crossover is. So getting rid of errors is relatively doable on QGIS. It almost always identifies them for you. And those three types are the vast majority of errors you will find on a typical shapefile, so they're good to look out for. We're going to go on to the basic setup of a shapefile next. I'm going to explain the CRS, and then we're going to cover base mapping in a little bit more detail. So, okay, so we've just basically done errors. I'm pretty sure that's all we need to cover on how to actually get the shapefile itself sorted. So we know how to make a polygon that is functional, and we know how to clean it for errors. So the next part is there are two other parts to a shapefile, along with the kind of polygons or perhaps line work that it contains, and those are the coordinate reference system, which I'm going to go over now, and the base mapping that you use against it. So the coordinate reference system is a fairly kind of abstract thing. So that's to do with how the map is actually presented on the screen. So you can have, for cartographers out there, you'll know exactly what I'm about to talk about. It's kind of Mercator projections and similar things. But basically, what you have, the fundamental challenge here is that you have a map of Earth, which is a globe, and it's a sphere. But we want to show it as a flat image, either on a screen or a piece of paper. So we have to come up with a way to format coordinates so that we can see the image of what's on Earth without the distortions being too bad. And you can see this on a world map. If I zoom out here, we've got a particular coordinate reference here. This is pseudo-Mercator or pseudo-Mercator. And this is very similar to the kind of globe, the kind of world map you would see on a school classroom, on the wall of a school classroom. So you can see here, because of the way the mapping is presented, Greenland is absolutely enormous, and Africa is not shown as large as it needs to be. So around the equators, there's a lot of distortion here, and the mapping isn't great. But around the equator and most parts of the world, there is a lot more accuracy. So that's why we use it. There are also regional variations. So if I were to change this mapping to British National Grid, which is what we use for almost all of our work because we're based in the UK, if I change this to British National Grid, you'll see that the distortion will become much worse. So we'll just let this load and become visible. And that's because British National Grid is a set of coordinates that define just the UK. So obviously it's a data set designed to make sense for Britain, but it doesn't really make much sense anywhere else. And you can see that here. So we've got a map where Britain is nicely shown and free of distortions, and the shape is relatively accurate. But as you saw earlier, the rest of the world is very heavily distorted and unusable. So which CRS you use is incredibly important, and there are three that we are typically using day to day. The British National Grid one, which I've just shown you here, that's because that tends to be used by a lot of UK companies. It's the most accurate reference system for areas of the UK. But the other two that tend to get used are the ones used by Google, which are WGS 84, which is exactly the same kind of coordinates you would see on Google Maps. And that is going to be a particular EPSG code, which I'm just going to load for you here. It's 4357. Oh, sorry, no, 4537. No, 4326, my mistake. So 4326 is WGS 84. That's basically standard globe coordinates. And that tends to be used for Google Maps. This isn't adjusted to make sense on a flat level field. It's just a sphere data set, so it's not the best. And we've also got 3857 here. That's a pseudo Mercator, so it's the same coordinates as WGS 84, but they're adjusted to compensate for the fact that we're on a square screen. So this tends to be a little bit easier on the eye. So it's those two. They tend to be the international formats. And then you've got the British National Grid format. So those are the three CRS formats that we tend to use. And again, it's very important to use the correct one because depending on who you're working with, it can result in the shapefile not being visible at all. So if I try and zoom to this layer here, you can see it's visible, even though I've created the shapefile in British National Grid, you can see it's perfectly visible against pseudo Mercator mapping. But if I change that to global coordinates, you'll see we have still got, it's still visible. So there you go. So it's quite good at polygons. And QGIS is very good at adjusting when it comes to the project CRS. But the shapefile itself has a fixed CRS. So I can't change the CRS of the shapefile without it causing serious problems. And if I try to do that, so if I just change it to 4326 now, you'll see it disappears. It becomes non-functional. And if we try to locate it, if we go on zoom to layer, we don't even know where it is in relation to the base mapping. So I'm going to change it back to British National Grid, and you can see that loads it in the correct position. Again, if I change it to 4326, it's gone. If I change it to 3857, it doesn't show up. So in order for me to change the CRS of this shapefile, I would have to re-export it in its new format. So that's important. If you have a shapefile in a given format that it's been saved in, you can't just change it on the fly. You would need to re-export it in a new format instead. So that is coordinate formats. Next one is base mapping. Right then, just to finish off, we're going to go on. We're going to just look at a couple of other alternative base mapping options for us. So I'm just going to load this back into British National Grid so I can see it. It's not distorted at all. There you go, it's better. So we've got our shapefile here, and we've got this in Google satellite base mapping. And the nice thing about quick map services is that we can select a variety of other mapping options here. So if I just type in Google and I type in map, you'll see I get Google Maps. And then if I turn off my satellite map, you see it's exactly the same. It's just in Google Maps style. We don't need to use Google at all. We're not restricted to Google. If I type in Bing, then I can get Bing Maps as well. There you go. I don't particularly like Bing Maps. Don't know why you would want to use it, but it's there. We've also got a variety of other options as well. So we've got the big companies and their mapping. You can really put any kind of image you want as the base mapping. It's just that obviously most people are going to want to put a map of the area that they want. But you can really go out there. You can actually on QGIS add a Mars base map. So obviously the location reference here isn't going to be correct because it's a totally different planet. But this is actually an image that you can load in QGIS that's showing the topography of Mars. I don't know what coordinate reference this is supposed to be in, but I'm showing it you purely to demonstrate that it doesn't necessarily need to be Google Maps. It can be something of your own. It can be just a blue square if you're doing your own map. But yeah, loading this is going to be a bit of a pain, so we're probably not going to bother with that. So that's basically it. You've got a variety of base mapping options, and sometimes it can vary. Which one you want can vary depending on how it looks, basically. So I think Google Maps looks okay there, but obviously the best one here for me would be the satellite, which is almost always what we're going to go for. And that's it. So you've basically gone through the basics there of how to draw a shapefile, format it correctly, make sure it's free of errors, and that it's put against a good, useful base map so that you can use it. All of those steps are basically how we draw polygons and interrogate them and just make sure they're clean so that we can use them for what we want to use them for. And we will be doing more videos on QGIS, so look out for those. But thank you very much for watching, and thank you.